In this session, we'd like to introduce a status update of OpenStack integration and give us some tips for tips on how to contribute it, and also we'd like to discuss about its future direction and the current hot topics. I'm Isaku Yamahata. I'm a PTL of OpenDaylight Neutron Northbound project and core dev of OpenStack Networking ODL.
Hi, I'm Mike Kolesnik. I'm a contributor to the Networking ODL project and a core committer.
Okay, so at first we have very limited time. So at first we'd like to talk about the current situation and how to its status update, and then talk about its right now V2 driver is a very hot topic. So we'd like to deep dive into it. Okay, this slide depicts typical deployment of OpenStack integration. Typically, we have three networks. One is for management network, another one is data network, which connects to each compute node, and the last one is a public network, which is connected to public internet. So our OpenStack Neutron is an OpenStack networking component which manages the network. And inside Neutron, there is a L2 plugin which provides a basic API for L2 service. And OpenStack Neutron is very highly configurable to support various kinds of technology. OpenDaylight is one of them. And so in order to support networking technology, we have, in order to support OpenDaylight, we have a driver component which works under L2 plugin, and which talks to OpenDaylight over management network. On the other hand, when a user sends a request to Neutron, like create a network, subnet, create ports, eventually it requests come down to networking ODL, and then networking ODL components talks to OpenDaylight to do a necessary action. On the other hand, on OpenDaylight side, there is a Neutron northbound component and also Netvirt component. Actually, OpenDaylight is a SDN platform, so there are various projects to support OpenDaylight component. Netvirt is only one of them, and there are various other projects to support OpenDaylight. So there are various overlaps. So OpenDaylight project decided to create a project to maintain a common component to support OpenStack integration. Now we are calling it Neutron Northbound project, which takes care of the communication between Neutron. Neutron northbound receives a request from Neutron and then stores related information to its OpenDaylight data store. And the actual backend, in this case Netvirt, actually looks into its data store and responds to its change. And then actually Netvirt programs actual network component like OpenMove switch to populate OpenFlow and so on. And then actually, and finally, VM can communicate with each other or connect to public internet. This is a basic deployment. This is the typical deployment of OpenDaylight and OpenStack. Now, networking ODL is a project under OpenStack. And OpenDaylight Neutron Northbound is a project under OpenDaylight. So naming is somewhat confusing, but that's how named. So those two components is a key component of integration, which actually take responsibility for communication between OpenStack Neutron and OpenDaylight. And if you are interested in it, those are the basic starting point of those links is the starting point. And actually, those two components works in tandem. So tandem. And actually, each project, those projects follows the practice of each project. Since networking ODF is an OpenStack project, so it follows OpenStack way. On the other hand, OpenDaylight neutral northbound is an OpenDaylight project, so it follows the OpenDaylight way. And there are cultural difference between OpenStack and OpenDaylight, so we need to understand that difference when you'd like to contribute to them. Sometimes OpenDaylight developers tries to contribute to networking ODF, or vice versa. Sometimes, I'm seeing OpenDaylight developers tries to contribute to networking ODF in OpenDaylight way. But so the behavior needs to be adjusted somehow. This slide shows it's how release is managed. Actually, OpenStack and OpenDaylight are different, so they have its own cadence, and release is a bit different. So we have some difficulty to align those release. Right now, actually, OpenDaylight case, Boron was released in September. And in OpenStack case, new release is planned on October. So there is a gap of release. But gap is about 1 month or so. Our next development focus is OpenStack Carbon and OpenDaylight Carbon and OpenStack Okata cycle. This will be a main focus of our development. Okay, actually, this matrix summarizes this previous slides in a different way. Actually, ideally, we should move this way, but actually, right now we are in boron plus Newton, and probably we will skip to carbon plus Okata. Actually, many various users require some more version combination, but at least in a development, focus will be on this diagram, this line. It will be work with Newton. Yeah, current plan is to deliver V2 driver as default, which is planned in October. We are working hard on it right now. Okay, so sometimes, as I said, there are several tips to contribute to both projects. The process follows a normal way of OpenStack or OpenDaylight. There are various kind of difference, but also there are various common way. OpenStack, also OpenDaylight uses Gerrit for patch review, and also they adapted CI, continuous integration, by Jenkins. So those tools are quite common between them. And also, actually, developers are common, same. Mostly same developers are working on networking ODF and also OpenDaylight. So actually, we understand how you behave. So just a matter of a principle, a matter of to adjust how to contribute it. For example, OpenStack does not require signed off by. On the other hand, OpenDaylight requires signed off by. So sometimes, OpenDaylight contributors sends patch to OpenStack with signed off by, but sometimes, so I have to ask to remove signed off by, something like that. And difficulty is some area requires both knowledge of OpenStack and OpenDaylight. So sometimes very few number of engineers knows both sides. And usually engineers tends to be on one side, only OpenStack or OpenDaylight, but those communication needs to be optimized holistically. So sometimes it is somewhat difficult to contribute area. But some area is quite, some areas requires only one side of knowledge. So I believe there are various areas to contribute to contribute with only OpenStack knowledge or with only OpenDaylight knowledge. Another big difference is OpenStack has, we have to maintain a stable release, but OpenStack has its own release, strict release policy, and actual stable branch management is maintained by a neutral release team. So it's not, it's maintained by another team. So sometimes we have some difficulty to backport patches into stable release. So on the other, sometimes we have some difficulty to support past stable release with new stable release. On the other hand, OpenDaylight case, backporting is quite up to contributors. So it's quite easy to do. That's the main difference. Okay, so this matrix shows our current status and future plan. I mean, Okata or OpenDaylight Carbon. Right now, actually, in OpenStack side, we are focusing on V2 driver and also pseudo agent port binding. That's quite. For V2 driver, we need to. Right now, we have a heavy race condition between OpenStack and OpenDaylight, so it addresses it. Pseudo agent port binding is to support more networking technology, data path technology. Right now, only OpenVSwitch support it, but we'd like to support DPDK-enabled OVS, OpenVSwitch, or VPP. And also, there are various kinds of data bus or software switching technology. So it generalizes the logic. On OpenDaylight, we have we supported various new APIs like L2 Gateway, SFC, QoS, and so on. And in future, actually, OpenStack Neutron is a moving target. It is continuously gaining a new functionality, so we'd like to keep up with it, and we'd like to also address more stability and so on. Okay, now I talked about V2 driver is quite important, so I'd like to pass my mic to Mike.
I think this one works. Yeah. Okay. Hi, I'm Mike. As Isaku said, V2 driver is pretty important in this upcoming version. So I'd like to give you a quick deep dive, explain what's the V2 driver, what's the concept, and see how it works, like generally. And I'd like to start by explaining that V2 driver is basically a name that we use, but it's more of a concept of how the networking ODL should work in regards to like the synchronization between OpenStack and OpenDaylight. So I'll talk a bit about how it works in the context of ML2, but you have to understand it also applies to the layer 3 plugin and also any other service plugin that there is, like VPN as a service and all the other service plugins. They should be like transformed to work this way, because that's the way that was decided a couple of cycles ago, that's the way to go forward in the regard of the problems that we had in the project. So let's see like a quick recap of how the V1 driver works. And basically like we have the create network request arriving via the router. It goes like first it goes to, let's say, the Neutron API. And the ML2 plugin receives it as part of the Neutron chain of events. And what it does, it writes it first to the database. So the network is being created stored in the database. And then there's a hook point that calls networking ODL driver, and the driver just passes it along to the Neutron northbound in OpenDaylight, right? So what happens basically for each call that we get, like the create network, or create port, or create router, whatever, it gets to the corresponding either this ML2 mechanism driver or the layer 3 plugin, and then that code directly calls OpenDaylight. So it's a very simple implementation, but it's very limited. It's like more suitable for a POC, not really for real use cases, because it hits like race conditions and some other problems that I won't go into, but if you know the history behind this, you know there are a lot of problems with the V1 driver. So the basic concept of V2 driver is just like the same happens. You get the create network, and it goes to Neutron, to the plugin, and the plugin writes it into the database. That all remains the same. We don't have any control over that. But when it gets to the networking ODL, instead of just sending it directly to the OpenDaylight node, we write it into a journal table in the database. And then there's a separate thread called the journal thread that reads this entry from the journal. And then that sends it to the Neutron northbound, like to the OpenDaylight controller. And what it does, it creates a separation of the concerns. So basically what we get is asynchronicity. So basically Neutron reacts faster because everything just gets written into the journal, and the maintenance thread just takes care of it later. The journal thread takes care of it later. And it basically fits the ODL design paradigm because OpenDaylight itself is very asynchronous. Like if you perform an API call on OpenDaylight on the Neutron interface, basically when you get HTTP OK, it doesn't mean that like the network was created or the port was created. It just means OpenDaylight saying, OK, I got your intention. I'm going to handle it, right? And it's also, sorry, you have a question?
Yeah, I thought the OpenStack actually did a post commit to make sure that the network was actually formed, and that's only time you can actually go look at the network. Even in this case, that would be the case, right? So how do you doing a post commit? Because if you're writing to a journal and then an error happens, it's not how is it communicated to the OpenStack?
No, so we write into the journal in the pre-commit step, right? So if there's any error writing to the journal, the whole transaction is aborted. No,
the error is on the controller node. The controller node says the OVSDB,
yeah,
OpenDaylight node says I cannot create this network. So when you communicate back, there's an asynchronicity. Right now what happens is you are stuck in the post commit. So when you do the post commit, you get the error back right away.
Yeah, so I'll talk about it later, okay, like in the problem section that we have. And we'll see, like maybe we can tackle it, maybe not. But that's a good question. So beside the asynchronicity, what we have is basically an ordered queue of requests. So it's solving like a problem where we had like the same resource could hit a race condition. Like if I update the same network twice, it could hit a race condition and then perform the updates like the other way around or something like that. So that's basically solved by using a journal, like a queue. And also we have like dependency validations that make sure dependent resources don't hit race conditions. And what we also have, we have like a DB level lock that supports HA deployments of Neutron. So basically, we lock on the DB layer, we lock each entry that we're gonna process. And then other Neutron servers know not to process this entry, like other journal threads in other Neutron servers know not to process this entry because it's already being processed. And it supports, of course, scale out. We can start more Neutron servers, and everything will be fine because it's synchronized by the database. And we also have some place for improvement, of course. So as you said, it's asynchronous now, so we don't have a good way to know like the resource state, basically. We do have like failure handling, sort of. Like if it's a temporary failure, if it's a network condition, then the journal thread knows to retry it later. So it doesn't fail the operation completely. And currently, we're also working on a recovery procedure to recover failed rows and to try recreate the resource or update or whatever is necessary. But there is a serious problem of not knowing what's the resource state, and it's actually also tied to the way ODL works, because ODL itself is asynchronous. So we need to have a good way in OpenDaylight to know the resource state, right? Like if I have a port, then I need to know like if this port is really up, and then it's consumable. And then we have like this problem of how to reflect that back to OpenStack, right?
So yes, OpenDaylight is asynchronous. You can have something in the config database, and it may not be part of the operational database. That's fine, but OpenStack is not that way. So I could issue multiple operations to find out that the initial operation that I had, because the general thread was busy and did not look at the first one that I issued, and I can keep doing those operations. I think a better way would be to mark it somehow in the OpenStack, which says this is not created yet, or block the OpenStack operation till the general stack actually does that, and not allow any other operation, because any other operation would first has to look in the ML2 database to find out that this basic element has been created.
Yeah, so that's a nice idea, but we need to think about how to incorporate it, because like in the networking ODL layer, we're very limited about what we can do, right?
And get the APIs that we want, rather than doing something which you cannot deploy in a big environment, or the kind of environments where we want to deploy this, where customers wouldn't want, enterprise environment wouldn't want this kind of thing. Yes.
Obviously. So we do need to raise that issue, and it's actually been raised before, but we need to keep pushing it in the greater Neutron community. And it's actually something I think we're going to talk about, right? Error states in the DDF later on. So that's like one issue that we have. Another issue that we hit with the V2 driver, and it's actually a bit related to the asynchronicity, because it frees up Neutron that fast. It actually has a backlog of operations to perform, and then it becomes a bottleneck. Like if you hit scale, either like just a big scale of operations. So what we think about is maybe like instead of having one journal thread per Neutron server, having it like API workers in Neutron, that you have as much threads as cores. So we need to see if that's possible. And also another direction, not really related to that, but it's like the dependency calculations. Currently, they're happening like each time an entry is read, which is not very efficient. Also, we want to move that to another place, to the entry creation time, which will slow that down a bit, but then we're doing it once and that's it. And also, the driver is quite complex now because like the dependency calculations and other areas are quite complex. And the more complex it gets, it's more bug prone, it's harder to maintain, so we need to simplify the code somehow.
Just asking, if we use V2 driver, what kind of scaling we can support? I mean, how many OpenStack compute node we can support?
No, you can support how many
What's
compute nodes you want, but it depends. Like, if you have too much requests going in, it could be a bottleneck. Like, depends on how many Neutron servers you have running.
Do you guys have
actually
idea, like
handling.
a couple hundred, like 100, 200? How many has been tested?
Right now, it's an open question, and we need to benchmark it. And, yeah.
So I have a more fundamental question is, the OpenStack Neutron interface is being used, the YAML2 interface is being used by other entities also, not just ODL. So how do they handle this problem? Because at that point, everything is seeing the same way, and they're not, nobody else is experiencing the problems that we experience with ODL. And I don't understand why that would be the case.
What exactly do you mean? Like other SDN controllers?
No, the ML2 has multiple drivers, right? So,
Yeah.
so one of them is ODL, but there are other drivers, and they are working with the same framework. So how come they don't see the same problem problems that we are seeing?
SDN is a different use case because SDN controllers, like ODL is not the only one to have these problems. Like every single SDN controller is hitting pretty much the same issues.
Okay.
And the basic ML2 drivers like the OVS and Linux Bridge, they actually have agents working, and they're actually pretty, like they're asynchronous, but they have like two-way communications.
Okay, so I think maybe this problem should be solved at the OpenStack level so that the other SDN controllers, after they're running into, they need to be.
Yeah, we need to like gang up and push it.
Yeah. No, actually, let me answer his question. Actually, various kind of SDN controllers attack this problem in various ways, really. Yeah, I looked at other SDN controller to do this, and this way, this is the way somehow we come up with. And some open ML2 mechanism driver, I believe, has similar problem. Especially young ones. Yep. And
so do we know if there are other mechanism drivers which have two-way communication? I think that's the fundamental problem, right?
No, actually, fundamental problem is how to think to state. Yeah, so sort of state mirroring. So this is based on idea of state mirroring to, for example, in DB case, they usually typical operational log and then send the operation log to remote and then replay there. So this is based on the such idea, which was already tried and proven with RDB space.
We're out of time. The closing slide.
Yeah. So actually, networking ODL and OpenDaylight neutron northbound are key components for OpenStack integration, and they are actively developed. And we want feedback for it, and we are looking for active contributors. Okay, we are running out of time. Probably, yeah. Any other questions? Okay.
No more questions? Okay, great. If anyone has any questions, feel free to ask us later. Okay, we'll post them to the OpenDaylight wiki. There's an OpenDaylight wiki, like
I believe so.
The slides. Okay, thank you very much for coming.
Into its data store and response to its change. And then actually Netvirt programs actual network component like OpenMove switch to populate OpenFlow and so on, so on. And then actually, and finally, VM can communicate with each other or connect to public internet. That is this is a basic deployment. This is the typical deployment of OpenDaylight and OpenStack. Now, networking ODL is a project under OpenStack. And OpenDaylight Neutron Northbound is a project under OpenDaylight. So naming is somewhat confusing, but that's how named. So those two components is a key component of integration, which are hot topic. So we'd like to deep dive into it. Okay, this slide depicts typical deployment of OpenStack integration. Typically, we have three networks. One is for management network, another one is data network, which connects to each compute node, and the last one is a public network, which is connected to public internet. So our OpenStack Neutron is an OpenStack networking component, which manages network. And inside Neutron, there is a L2 plugin, which provides a basic API for L2 service. And OpenStack Neutron is very highly configurable to support various kinds of technology. OpenDaylight is one of them. And so in order to there are various projects to support OpenDaylight component. Netvirt is only one of them. And there are various other projects to support OpenDaylight. So there are various overlaps. So OpenDaylight project decided to create a project to maintain a common component to support OpenStack integration. Now we are calling it Neutron Northbound project, which takes care of the communication between Neutron. Neutron Northbound receives a request from Neutron and then stores related information to its OpenDaylight data store. And the actual backend, in this case Netvirt, actually looks. In this session, we'd like to introduce a status update of OpenStack integration and give us some tips on how to contribute it, and also we'd like to discuss about its future direction and the current hot topics. I'm Isaku Yamahata. I'm a PTL of OpenDaylight Neutron Northbound project and core dev of OpenStack networking ODL.
Hi, I'm Mike Kolesnik. I'm a contributor to the networking ODL project and a core committer.
Okay, so at first we have very limited time. So at first we'd like to talk about the current situation and how to its status update, and then talk about its right now a V2 driver is a very both networking technology. We have in order to support OpenDaylight, we have a driver component which works under ML2 plugin, and which talks to OpenDaylight over management network. On the other hand, when a user sends a request to Neutron, like create a network subnet, create ports, eventually it requests come down to networking ODL, and then networking ODL components talks to OpenDaylight to do a necessary action. On the other hand, on OpenDaylight side, there is a Neutron Northbound component and also Netvirt component. Actually, OpenDaylight is a SDN platform